M1 Kinematics Example 13. This is another example where we're looking at motion under gravity. A ball is projected vertically upwards from a point X, which is 7 meters above the ground. So this point here, where we're starting from, is 7 meters. The ball's projected vertically upwards with a speed of 21. We've got to find the greatest height it reaches above the ground. So we know that at the greatest height, the ball will be instantaneously at rest before it falls back down towards the ground. Now, because the initial speed is upwards, I'm taking upwards to be positive, and so acceleration will be towards the ground. That's the opposite direction, so that's negative. The thing that we want to know is how far has it gone? So S is the thing that we're looking for, the displacement above the starting point. Looking at those variables there, V, U, A and S, I think that this is the correct identity to use. V squared is 0, U squared, 21 squared, and then we've got 2 times A times, and we don't know what S is. Okay, this is all one term here. 2 lots of 9.8 is 19.6, and 21 squared is 441. So we've got 441 minus 19.6s. That's just a linear equation. If I bring the 19.6s over to the left-hand side, that will become positive. And then just dividing through 441 divided by 19.6. And that works out to be 22.5. Now, if you read the question carefully, it says find the greatest height above the ground reached by the ball. Now, we've got to be a little bit careful because we started 7 meters above the ground. So, if I want to know where this point at the top of the motion is, it's 22.5 meters above the starting point, but it started 7 meters above the ground. So actually, it's 22.5 meters plus the 7 meters we already were above the ground. So it actually ends up 29.5 meters above the ground. So it's really, really important to read the question above the ground in that case. Okay. Part B, the time of flight of the ball. Time of flight means until it stops. Now, when will this ball stop? Well, it'll go up and come to instantaneous rest, and then what will happen? Well, it'll fall. So it'll fall down. It's not going to stop there. We haven't been told that there's a shelf or anything that's going to stop it. So it's going to keep falling right the way down to the ground. So we know again that our initial speed is 21. And we know that our acceleration towards the ground, which is in the opposite direction, is 9.8. The thing we want to know is t, that's the time of flight. And then we know one other thing. We know that from this starting point, the ball may have travelled up and come back down to the floor, but the actual displacement from the starting point is 7 meters below where we're starting from. So displacement of 7 meters below the starting point means our value of S is -7. So well done if you spotted that. Okay, so which equation? Well, it's going to be S equals UT plus the half AT squared. So S is -7, U is 21, so it's 21T. Half of A, I'm going to do that in my head, half of that is -4.9 T squared. Now we've got a quadratic, but earlier on we just factorised this side by taking a t out. We can't do that in this case because we've got a 7 over on that side. So if I bring everything over to the left hand side, the 4.9 t squared will be positive, the 21 will become negative, and the 7 is negative. So we've got a quadratic equation that we need to solve. Now, I'm going to have a little hunch that this is not factorisable, and so we need to use the quadratic formula. And if you remember, the quadratic formula is minus b plus or minus square root of b squared minus 4ac all over 2a. Now I'm going to go through this pretty quickly because you should have done this in C1. So if you're not sure, just have a look back at your C1 notes. So the value of t here is going to be minus b, which will make that plus 21, plus or minus square root of b squared. Well, minus 21 squared is positive 441, minus 4 times a times c. C is negative 7. And all of that is divided by 2a. Well, 2 lots of 4.9 is 9.8. Okay, so if you were to type all of that into your calculator, have a check by pausing the video at this point and make sure that you get the following two answers. So the answers that you should have got are 4.5965 or minus 0.3108. So which of these is correct? Well, we can't have a negative time. The negative time represents what would have happened if we'd started from the ground. So it would have been 0.3 seconds to get to that starting point. That's why we've got a negative time. But that one isn't the one that we want. If the ball's gone up in the air and come back down, this is the one that we're looking for. So T to 2SF is 4.6 seconds.